everyone. In this video, we're going to talk about data manipulation basics with dplyr. Okay, so you'll see at the beginning of every video or at the beginning of my slides, I'm either going to have what book the material was referenced from if it's not our main book. And so you may notice that at the beginning of our functions video, I had some books there that will help you as references if you need help with functions. And then here I have the hex sticker for every package that we're going to use. So usually my slides are going to be about a single package and what it can do. And so here is the hex sticker, which is this hexagonal sticker that people love in R. They just absolutely love these hex stickers to collect them, put them on laptops, so on and so forth, if you like/use the package. So anyway, at the beginning of the slides, I'll always have the hex sticker for what kind of package that we're using. So maybe it will help you. Maybe it's just fun or not fun. It's fun for me. Or maybe it'll help you keep track of everything. But anyway, data manipulation basics with dplyr. Now I want to go back to one of the motivating examples that I used in the very first day slides about data science. And specifically, I said it was about data manipulation. So it was back to these fake-ish grades. So these are actually real grades for people, but I took away their names. And so in one of the classes, this is a math for liberal studies. Okay, but anyway, I have 25 students. Their grades are here. As a reminder, this class had homeworks, quizzes, and exams. And so there are roughly 23, I think, or 24 homeworks, 6 or 7 quizzes, and 3 exams. And so the question is, how do I calculate, we're going to go here to my R, and the question is, how do I calculate their grades? How do I calculate their grades in a systematic way by manipulating the data? So the first way, before I started using R or thinking about how to do this in R, I would have an Excel gradebook, and I would create some formula that could be fairly intricate that applied to each row, that averaged together the homeworks and averaged together the quizzes and averaged together the exams. And we're going to do the same thing here. And then, of course, in Excel, you could just take the formula that you did in one cell and you drag and drop to do for all of them. Now, I'm not saying that R is going to be a better way, but we are going to have to think a little bit differently than how you would in Excel. Now, the final grade. So I'm writing in a regular old R script, and I'm making use of comments, which is, well, helpful for you, but I think helpful in general. Whenever you code, you should make as many comments as possible to tell both you, for your future self, if you have to go back and look at that code, and for anyone else that has to look at that code, what the heck is going on. And so I've loaded the data in here, but I'll run this again. Here are the 3 grades that you average together, and then each of them is worth 35%. So I calculate my final grade by doing 0.35 times the homework average plus 0.2 times the quiz average plus 0.45 times the exam average. Okay, so the grade is not really that hard to do. But sort of the question is, how do I get, I've loaded these before, so it's not going to pop up with everything that it would for you if you were to run this. You also don't have the fake-ish grades. So you can't quite do the same thing that I'm going to do here. But I will give them to you in the supplementary materials for this week so that you can follow along. But anyway, and remind me if I don't do that. The final grade there is not very hard to calculate, but what I want to do, or what you're going to learn in these set of videos about data manipulation basics, is how to take grades, which looks like this. It's a Tibble 25 by 33. Think of it like an Excel sheet. In fact, another thing that many people love when starting to use R, again, personally, I don't like this feature, but I'm in the minority. So if you hover over grades, so you come up here and just click on grades, okay, it runs a function called view grades down here, and then creates an Excel-like spreadsheet of all the grades. Okay, and this is very helpful when you're learning to look at data in R. Now, I'm going to teach you functions that I hope will supplement using view, although it's, I don't know, I've tried saying that before and it has never really helped. People love that option, that function. Okay, but so when I do this, what I want to do is, and I asked you to think about this in the very first video, but I don't think that eloquently. How would I calculate these grades? And so you might have said, and rightfully so, well, I average the homeworks, and then I average the quizzes, and then I average the exams, and I put them all together. And that is absolutely right. Absolutely correct. But then how do I do that in here? So the questions that I want to know is like, how do I, first, I guess what I want to make sure that we do is I'm going to create a separate data set for each one of the homeworks, quizzes, and exams. It may not be the most efficient way, but I think it is the best way personally for me for doing this. So I want to separate the data into just homeworks, if I can spell, homeworks, quizzes, and exams. So really what I'd want is three data sets. I'm going to call them data frames because that's the language that we use in R. 3 data frames. One that just talks about homeworks, one that talks about quizzes, another one that talks about exams. And so how do I do that? And specifically, what's the best way? There are many ways. What's the best way? We're going to learn about verbs that will act on the data. Okay, so specifically for creating a data set that just has the homework scores and, of course, the name of the student, well, that means that I would have to select out just homeworks. Okay, and so the important word there is select. And if I would only want to filter out students who got an A in the course later on, the important word there is filter, the verb. And so those are going to be important to what we do. Okay, so how do I select out just homeworks, just quizzes, just exams, so on and so forth? That's what we're going to learn here in just a second. So here's data manipulation. So we're going to go and talk through the basics. So we'll talk about the tidy data principle for just a second, and then we'll work on the basic functions. First, we're going to manipulate rows, then we're going to manipulate columns, and then there's some other functions that are going to help us also in the future. And so we'll split this video up into a couple parts. We'll just do the rows first, then we'll work on columns and others. So dplyr is a package, part of the tidyverse, so it comes downloaded and libraried when you library the tidyverse, and it's the main package for data manipulation. Some people call it the grammar for data manipulation. So for ggplot was the grammar of graphics. Here we have a grammar of data manipulation. Okay, so dplyr expects that the data will be in the tidy format, or will be in a tidy format, and we'll talk about what that means in a second. Okay. Third, if you've ever used SQL or SQL or whatever you want to call it before, the verbs that we're going to learn, the functions that we're going to learn are going to sound very similar. They have a very SQL feel to them. Okay. And then the last important thing that I think you should know about dplyr are that they follow the same argument structure. So for any dplyr function, the first argument is the data, which has to be a data frame or tibble. Okay, we're always going to work with data frames and tibbles. Other things which you've learned are like vectors, lists, so on and so forth. We need data frame / tibbles here. And then the subsequent arguments describe your actions. So it's always data and then actions as the arguments of any dplyr function. Okay? And then the result, the output, is also a data frame. So you're never going to get anything out of a dplyr function that is just a number. It's always going to be a data frame. So what does that do? That helps you chain together, or you'll see in just a second, pipe or chain together multiple dplyr verbs to make what people will call a data analysis pipeline. Okay, so first, what's tidy data? Tidy data is the mantra of the tidyverse. It is a paper written by Hadley Wickham. Again, that name comes up often in any sort of data science class that uses R. The basic principle of tidy data is that every row is a case, every column is a variable. Okay. So every row is a case, every column is a variable. We have that in our fake-ish grades. Here, every row is a case, the person, and then every column is a variable, which is a measurement on that person. A measurement taken very abstractly. Okay, each homework is a measurement of that person's work on the specific material they're learning, so on and so forth. Okay, so I have it linked here. If you'd like to read the paper, you can click on the link, and we'll spend a large amount of time tidying data. Okay, there's another package similar to dplyr called tidyr, and we'll also take a look at that in the next video for data manipulation. So something that RStudio has for all of its Posit, which used to be RStudio, has overseen a lot of the creation of these packages, the tidyverse, so on and so forth, and they provide these cheat sheets that can be helpful if you like this sort of thing, that you might want to print out when you start to code, that can help you remember which function is which. And so I'll also put these at the beginning of every slide when slide deck for a particular package. Now this one is a little bit old, again, because they have RStudio and not Posit. You can find them and they update them regularly. Okay, now let's actually get into the functions in dplyr. I mentioned this one before. It is the filter function. So we're manipulating rows. And so if I want to, remember rows are cases. So filter, as the name suggests, is going to filter by keeping filter the rows by only keeping qualifying rows. Okay, and the filter function, oh sorry, my builds are off here. As promised before, the first argument of filter is the data. The second argument is one or more logical tests to match. So you want to filter by something. The by has to go in the ellipsis. Okay, and so here, if you remember back to our functions video, the ellipses can happen in two places. One in which, well, the first one we don't need to worry about very much. The second one was when you have a varying number of inputs, and this is the varying number of inputs case. So I have a little sample tibble down at the bottom that has a combination of characters and integers, 3 columns X, Y, and C, and we're going to use that little tibble to see how filter works. So, for instance, I have this line of code, TB, and then I have something interesting, and we'll get to that in a second. And then I have say filter, excuse me, x equals 1. So there's a couple of interesting things going on here. The first one that I will address is that thing in the middle that is the percent greater than percent. This thing is called a pipe. A pipe. Specifically, this thing is called the Magrittr pipe. Magrittr. M-A-G-I-T-T-R. Magrittr pipe. It's a special pipe. It's a special thing in tidyverse. That so Magrittr is a package in tidyverse that only has pipes in it, and this is the basic pipe. All that a pipe does, so this operator, think of it, it's the same as it's not the same. It's like a plus. So 2 plus 2 is an operator. The plus is an operator. It takes the thing to the left, takes the thing to the right, and adds them together. Here, this pipe, this operator, is going to take whatever is to the left of it, in this case, TB, which I'm calling that small 5x3 data set to the left, and it plugs it into the first argument to the right of it. Okay? So it takes TB and it plugs it into the first argument of filter. Okay, now, so I could equivalently write filter TB, comma, x equals 1. Okay, so those would be the same things. Now, if we get past the pipe and we get to the part where we're in filter, x equal 1, okay, notice it doesn't say x is set to be 1, which would be 1 equals, 2 equals, tests for equality. And so it's going to pull out how many rows exist where x is 1. Only 1 and only the first row. So it's going to filter and pull out the first row. Okay, hopefully that makes sense. Okay, here are all the logical tests that you can use inside of filter. Okay, less than, greater than, equal to, less than or equal to, so on and so forth. We'll use a varying number of these as we go throughout the course. Common mistakes when using filter. Well, that first one, you're setting it to be equal to 1. Okay. Both of these have functions, so both of these are wrong. Both of these are going to have problems. What's wrong with them? Think about it. If you want, pause the video. Okay. So what's wrong with the left one? The left one is setting, not checking. So you want equals 1. Okay. The right one, it's going to error. It's going to say object A not found. Okay. You need to match the type of argument of which C is. C is a character. vector or a character column. And so you need to say A is, A is a character, and characters are made with the single or double quotes. And so you need to say C is equal to quotes A. Okay, filter can take in multiple logical tests. Here's how you do it. Either the comma, remember because of the ellipsis, or the ampersand, the and. Okay, so you can take in as many as you want. Here's some more logic that you can use with filter. Okay, ampersand is the A, the vertical bar or the vertical pipe, some people call it, is or, and the exclamation point is not or reverse. Makes true false and makes false true. Yeah. Okay, and so here's some Venn diagrams about what each of them would be that are helpful when thinking about it. Okay, so that was the first one. Filter. Arrange. Arrange arranges the rows, which is not so exciting, or rather makes total sense. Okay, by default it arranges it in ascending order. So this is like a sorting from highest to lowest. Okay, so if I take the tibble, I pipe it into a range. So first argument is TB, second argument is arrange, so it's arranging Y in ascending order. So original data set is up in the top right. That's going to be my new data set. Okay, instead of 1, 2, 2, 3, 1, now it is 1, 1, 2, 2, 3, and of course the whole row goes with it. Okay, it's not only the Y column that changes, everything changes. Okay? If I want to go in descending order, there's a helper function, the DESC function. Okay, DESC, it'll help us sort in descending order. You can also arrange on multiple variables, sorry. Okay, Y then C, or Y and C. So you say it's going to do Y first, then C. Okay, now where would that change? Would that change anything? It breaks ties in Y by the value of C. And so also interesting to keep in mind that it's going to use alphabetical order for characters, and of course numerical order for numbers. And so it doesn't really make a big difference for what we saw here. Sorry, if we go back and you look at this new data set on the left right now, it goes 1, 1, 5, 1, 2, 2, 3, 2. And what changed is if I break ties with C, okay, it now goes 1, 1, 5, 1, 3, 2, then 2, 2. So it's that third and fourth row that switched because there was a tie for 2 and 2, and the A versus B broke that tie. Okay. You can also go in descending order, which that's going to flip it back to what it was before, because B would come first before A. So lines 3 and 4 are now switched again, but for that sort of descending opposite reason. Okay. Ties are broken left to right with multiple variables, or first left and right in the way that they come in the argument. Okay, slice. Slice allows you to select certain rows from the data. So maybe I only want the first 50 rows, or the first 15, or the first 5. Slice is going to be what I want to use. Okay, so slice 1 gets you, well, the first row. So you can slice by position. You can slice multiple rows. This says 1, 2, and 3. 1, 3, sorry, 1:3 gives you a vector of 1, 2, 3. And you can slice by not. Minus is very similar to the exclamation point. In fact, the exclamation point works here too, I believe, but the minus is more conventional. So I want everything except 2 and 4. So you see, it'll give me 1, 3, and 5. Okay, now we're going to stop. Actually, we're going to stop here, and I'm sorry, no, mutate is still a row. I want to make sure I stop, and so we get a new video for columns. So, sorry. I'm just going to stop here. We're going to start with mutate in the next video. Sorry about that. See you next time.